Hey guys, I just wanted to make a video on this because it's something I haven't done before. But what I did recently was I bought a whole load of components off of Amazon. Now, as I've said, that's not so. I never buy these cheap little kits. If you've ever, actually, I've never really shown you in my component drawers, but my stuff's all, as you can see, that's on semiconductor, all legit parts. Like ST micros, CTBCs, right? You get the point. So whenever I order components that I suspect could be, counterfeits or fakes or just falsely advertised as a different component to what they are, I put them in separate drawers. So that's why I've got this whole drawer here that's got a lot of the exact same standard transistors in it that I've got over in these drawers. That's why these two MOSFET kits, they're both the exact same kit. It's just that when I build stuff, I need a lot of the same component. Like if I'm using these for, say, a motor controller, I might use 3 or 4 for each phase. That's 9, 12 MOSFETs, could be more, so I wanted to order 2, so I've got, 10 of each. But again, on visual inspection, some things say that they look real and some things say they look fake. Like some of them, they look like they're actually laser etched and they're not sanded down. You can still see the number inside the middle there. The tab looks all legitimate. The legs are copper, not steel. They look fairly good. And they test on component testers and the Atlas 75 DCA Pro. They test good. So, like, they test within their specs, is what I'm trying to say. Now, the two specs I can't test right now is the breakdown voltage, right? The RDS on resistance. Like the Atlas DCA Pro will tell you if it's less than 1 ohm, but that's not very helpful with FETs when you need to know if it's 0.22, 0.56, 0.04, 0.011, 0.16, 1.5. You could have a lot of different resistance values for your RDS on figure, right, with MOSFETs. So the thing is, you're going to need to be able to measure their characteristics. So what I've done is I've ordered, I think if anyone watches a few other electronics channels out there, they might have seen people reviewing this little Chinese, it looks like the cheapest, shittiest little tool, but basically all it is a device that makes up to about 2.7 kilovolts, a couple milliamps, adjustable, and you can use it to test the breakdown voltage on like silicon junction devices, transistors, MOSFETs, thyristors, triacs, all that sort of stuff, right? Diodes. So I've ordered one of those so we can test breakdown voltage, and I'm going to design and build a tool to measure the RDS on value at different gate voltages and different drain currents and stuff like that. And I'm also going to design a tool to measure the gate capacitance and the effective drain to source capacitance and all those sort of parameters too. So that's a couple of things we've got coming up, because what I've decided to do is basically order some cheap and crappy components. Look, I've had some fairly decent luck. I'm not with this kit. This kit was full of a lot of rubbish, but as I said, most of these MOSFETs actually look and test okay for now, but because I can't test the breakdown voltage or the RDS on figure, I won't know until I get that tool and build the other tools I was talking about. But a lot of these transistors I tested for gain and VB drop and all that, and they're all different and they all match the datasheet values, like almost precisely. Like it actually shocked the crap out of me. I really don't know what to say about that. So, yeah. Those 560Cs and 550Cs are from a different seller that sold me all of those transistors. And I do have some BC 550s that they've got to be fakes because they've got a really low HFE and a really low VBE drop that's weighed, but like the HFE is around 25. It doesn't make sense. I've got some BC 546s that are off eBay. I can't remember why I put them in there. There was some reason I came to the conclusion that they're counterfeit and not actually BC 546s. Actually, no. Right, I've tested them and they test like BC 546s for gain and VB drop wise. I haven't tested breakdown voltage on them. So that's why they're still there. Actually, as a matter of fact, because all these transistors are fake to be tested, I'm actually, after I do the video and recording, I'm going to put them in those two drawers and free up this drawer because I'm always running out of space. But anyways, so with this pile of components, where do I start? These little ceramic capacitors are absolutely hilarious. So I'll just show you for a quick example. They're all completely wrong. Like, it's absolutely ridiculous. These ones are 104s, 100 nanofarads. How can I do this with one hand? Hold on a sec, I know how to do this. Because I modified my LCR meter, I added banana jacks. So that now I've got my positive and negative supply and my positive and negative sense and guard, and I can run external leads. Yes, I am going to redo this with BNC jacks eventually. And then all I have to do is slip this little piece of card with Captain tape around it in these two jacks so that the two bits of metal aren't touching in there, and that opens up my access to those 4 ports. But I can also unplug it. Sorry, my hand's in front of the screen. I can also unplug the leads and pull that thing out and slide a component in there like it's supposed to be. So that's why I've done that like that. And yes, this is calibrated and accurate. So 100 nanofarad capacitor comes in at 60 nanofarads and slowly going up. Let's go up in frequency. Doesn't make a difference. Yeah. Okay. Rightio. So let's have a look at ASR. Okay, that's a low frequency for a ceramic. Let's go 100 kilohertz. That's supposed to be 100 nanofarad capacitor. Should be around about an ohm or something, I think. Well, here's the second most hilarious thing. These 100 nanofarad 50 volt caps, these are just from J-Car. They're nothing special either, but they're at least real. Just have a look at this. Oh, turn around. It's freaking half the size. Oh my god, these Asians, I tell ya. So an actual 100 nanofarad. Okay. I guess disc ceramics are just crappy capacitors. I don't really use them much, as you can probably tell if you look in my drawers. I mainly use monolithics and film capacitors and MKTs and stuff like that, so I'm not too used to these. I knew they had a fairly high ESR, but maybe down at 1 kilohertz it might be different, or 10 kilohertz. Oh God. Wow. Okay. But you see, that's still climbed up to 90. That had still climbed up, and it's still a lot higher. Oh, hold on. No, my leads wasn't in the freaking socket. See? Now that's still not, in my standards, a great capacitor. But, you know, at least it's in the 10% tolerance that it should be, and it holds up to its voltage. I guess the ESR's in the same ballpark, but here's the thing that I really wanted to show you guys, right? Not just the size is literally half the size of the correct counterpart, but look at this. Sorry, that's also a 104. See, they're all exactly the same. Now check this out. These ones are bigger, right? But a smaller capacitance. 683, 104. So 683 is 6, 8 and 3 zeros. 104 is 10 and 4 zeros. So 100 nanofarad, 68 picofarad. Right? The 68, or is it 680 picofarad? Either way, it's still... Look at this. It reads it's like a 68 nanofarad capacitor. That should say 684. Not 683. And yet, it's got the same capacitance as that. Did these guys just grab like 1,000 of the same 56 nanofarad capacitor blocks and then just encase them all and put different labels on them? I mean, I genuinely don't know what to say about this. Let me just set the phone down for a sec. Because I've got so much more to show you, so I'm just going to put this rubbish away. I'm not going to even bother testing all the other values of these. These are clearly absolutely rubbish, and I wouldn't even think about putting them in a circuit. What I'll do, because there's so many different values here, and who knows what they are, I'll just leave these in a box. Because they have decent ESR, like the ESR value is the same as the 50 volt caps, I'm going to derate them to 25 volts. And, well, obviously the values on them aren't correct, but when I need some really, really low voltage caps, I might use these. If it's not a critical circuit that doesn't need any sort of precision, and it doesn't need some like special NP0 capacitor or X5R or X7R or monolithic or whatever. Yeah, I think I'm just going to call them 25 volt random values to be tested upon use. Honestly, I might even end up just throwing them in the bin. I hate to waste stuff, but this is just rubbish. There's really no other way to put it. I'll keep them in case my missus wants to learn electronics. She said she wanted to play around with electronics and get into it. She's obviously going to need to start with some just basic components that the values aren't so important of, just to light up LEDs and build little 555 timer circuits and all the stuff that people do when they're learning. So I guess I might just put all this stuff off to the side. I don't know. It's either just going to go on little breadboard, 12 volt projects that are meaningless, or it's going to go in the bin. I can tell you that. It ain't going anywhere near these drawers. Anywhere near them. Now the diodes, this is really interesting. Turns out the diodes appear to be real. I'm not going to say they are. They appear to be manufactured by this company called MIC, which is an Indian manufacturer of semiconductors, and they're actually a good manufacturer, MIC. The problem is people counterfeit MIC. So the thing is, the counterfeit ones usually have a number at the bottom of them. Usually. So you'll get the number of the diode at the top, like 1N5408, and MIC at the bottom. And the counterfeit ones will either look like exactly the same as this, but the ink is like all rough and like it's not as easy to read the writing, is what I'm trying to say. And the other ones I've seen that are fake, they have numbers at the bottom, not the MIC brand. From that and the forward voltage drop on them and junction capacitance, they seem real, but I still don't know until I get that high voltage tool, because then, you know, like all these diodes have got different breakdown voltages. I can actually test a couple of them and see if they're in the ballpark or not. One thing that's thrown me off a bit is these 1N4007s. So again, we'll just go to my 1N4007s. There's a couple of 1N4002s in the back there. If we look at my definitely 100% legitimate, because I know where I sourced these diodes from. Do you see the lead thickness size difference? I know they're only like a 1 amp diode or whatever, but and that can handle 1 amp, but you got to understand the package size and the lead's not just there to handle the current, or not the package, the lead. Ooh. It's actually there so that it can act as a thermal dissipator, like a heatsink. So if you make smaller leads and a smaller package, even if there is a 1N4007 in there, you're not going to be able to run it at the power you would run those ones at. So I could be wrong. They could still be alright. Because I have seen, I've worked on literally hundreds of thousands of circuit boards in my lifetime, and I've come across plenty of these smaller 1N4007s, and I've noticed them before. The package isn't smaller, just the pins. I've noticed that before, and I've found them on rectifier circuits that are rectifying mains. So oh no, which way did I put the phone in? Oh my god, I hope I'm not... Wait, let me think about this. Put the phone there. Okay, so it's probably holding you guys like that. I just realized that there's a possibility I might have just flipped the video upside down, and I don't want to do that. Anyways, so yeah, these are not going to get put away until I've tested them for breakdown voltage. So I guess they can stay in there for now. Now, I got all these Chong-X capacitors. As soon as I saw Chong-X with the VEHT on it, I was like, oh, okay, yeah, fakes. And I've seen people do videos of these where they've taken them, and I've tested a lot of these. As you can see, I've got my other power supply on, and it's set at 30 volts, and we'll put the output on. There you go, 30 volts. And it's in series with my supply, which is set at 20 volts. So there's 50 volts there. And Oh, shit. I just realised what I was doing. I wasn't putting the 50 volts on for that. It's a 16 volt cap. I wanted to put 50 volts across one of these little 50 volt rated caps and see if it goes pop. And then I wanted to crank the voltage up more. That was almost a silly move, eh, guys? Well, it's not even warm. I'm watching the current on my meter. Oh, okay, so it's sitting there at 5 milliamps. 6, 7, 8. Oh, it looks like it's about to break down. I'm just going to turn the voltage up on my power supply a little bit, a couple volts. Maybe more than a couple volts. I'm going to go up to 60. 55. Okay, you know what? I think that's just the leakage. I'm going to now go test a genuine one. My power supply is running at 30 volts, and the other one's running at 30 volts. That's 60 volts on that little 50 volt rated cap, and it's not warm. We'll leave it for a soak test. I'll leave it sitting like that for a little bit. One thing I do want to do though, I'll just grab a 10 nanofarad cap here. 10 picofarad. Put you guys back here for a second. I just want to see, because if you look at the power supply, you see we've got this little 5 to 9, it drifts around, milliamp draw. And if I disconnect the capacitor, let me just make sure that's not false reading because it's hooked up. Oh, that's false reading, guys. That's still there. That's just because it's hooked up in series with the other power supply. There must be some common mode leakage off of that switcher, and it's messing with the measurement being in series with another supply that's decoupled to ground. Okay, well that's good. So there's no leakage on it, and it holds up to 50 volts. This one's 152. What does it measure? What the what? Am I tripping balls that was just literally saying like 200 picofarads and then just jumped up to... I've got to do that again. Or was it just on the edge of being counting over? Okay, that was me. See, they're not 152s either. None of these capacitors are the value that's stated on them. No, I mean, they're not even close to it, not even like 20% tolerance. They're just absolute crud. And yeah, these are NP0s. That's what the black dot is on there. Sorry, just realised you didn't see that. These are my ones. Yeah, I always order good stuff. That's why, like I said, like I've not done this before. All right. We'll put this back in here, and my good one back in my good box. Sip of coffee. Right. So let's I don't need this now. Yes, I've got to move the power switch from the back to the front. It's so bloody annoying having to reach around the back to turn it off. I don't know who came up with that idea. So I'm going to start off at 16 volts. It's rated for 16 volts. It should be able to handle at least 18. And I'm not worried because I did this before to a bunch of these. And I'll just show you. Not even warm, not even slightly. So I gotta say I'm absolutely shocked about that. Because I've watched other videos where people have started putting the voltage up and they've got up to like 5, 6, 7, 8, say 9 volts even. And the things have just gone bang. So, like the other capacitors that I've got, they hold up, the little ceramic ones, they hold up to their voltage rating. But I know you're not supposed to short them out like that. It's not good for them. I know. We don't care about these ones. This is a 470 microfarads. It is an electrolytic. It should be tested at 120 hertz. The ESR's there, but again, so you see what I mean? All these capacitors, the electrolytic ones and the ceramic ones, the ESR and the voltage rating is correct, but the capacitance values are all off. These are all just slightly under. So, leave them in there. Don't worry guys, it wasn't all bad. I checked out the pots and I added all the pots, the single turn ones and some 10 turn or 25 turn pots to my collection because they were all good, and I can't remember what else that was in there. Oh yeah, the voltage regulators, they were genuine. The LEDs were all genuine. Haha, I know they're only LEDs. I'm 90% certain the diodes are genuine. Oh yeah, the proto boards too. I got them, and they're actually reasonable quality. Proto board. So far it's just the capacitors, and the ESR and the voltage isn't wrong, which is honestly the main two things that's going to ruin your day. But I guess the capacitance figure is going to ruin your day too if that's not there. So, last but not least, because these transistors, I can't do anything with these yet. All I could do is test their parameters, and they're probably just going to be the same transistors I've got in here anyway. All I can do is test their parameters and say, yeah, they're probably right, but until I get that voltage breakdown tester tool that I was talking about, and design an RDS on measurement for MOSFETs, we're not going to do a video and analyze transistors and FETs just yet, because I want to have the right equipment here to do it properly so I can give you guys a definitive answer, because I'm sick of people on YouTube like, yeah, I don't want to, alright, I'll say it, learn electronics repair. The guy's a nice bloke, alright, he's a wonderful guy, but he needs more experience, and he reviews tools, and to him they're great, and the sad reality is absolute crap. It's just, they're not crap until you get into the high bandwidth region, or you're doing something complicated that's outside of his expertise, so he doesn't notice and he thinks it's good and he gives it a good review. I've seen other channels, it's not just him, he's actually pretty good at fixing stuff compared to a lot of the people I've seen. He's starting to actually realize that there's fake components out there and all that sort of stuff, and he's actually built an RDS measurement device himself and got the same voltage breakdown tool that I've been talking about. So he's obviously been aware of fake components over the years and all this sort of stuff that's going on, and he's getting there. But I have seen him at the same time use questionable components in people's products that he's repairing, and I've seen that and just gone, hey man, what are you doing? But anyways, that's my rant on that. I don't want to give the guy a hard time. He seems like a really nice bloke. So yeah, I'm not gonna test those in this video until, like I said, I've got the proper tools, because I want to give you guys a 100% definitive answer. Like, we'll put it on the Atlas DCA Pro and we'll trace some curves and we'll look at some graphs and figures and stuff, and we'll compare it against the data sheet, and then we'll put the breakdown tester on it, and we'll test the different junctions and their breakdown voltages, and then only then will I say to you guys, you know, they're good, they're not. We'll try and take some measurements on the scope too of like rise and fall time and stuff like that. I don't know if my equipment's going to be fast enough, but we should be able to get some meaningful measurements out of some of the bigger devices. Anyway, moving on now to these resistors. That advertises 1/4 watt metal film 1%. Now, to most people this is the size for 1/4 watt, but that goes back to the carbon composition days. Not only we're out of carbon composition days into carbon film, but we've succeeded carbon film and we now have metal film. So the devices end up being a lot smaller, and I can show you that because these are all 1/2 watt resistors. 1% again. And yet these ones are advertised as 1/4 watt. So I'm really curious. So the two things I'm going to do to identify this is I'm going to get two resistors that are the same value, like say this 10 ohm resistor. Alright, I'll take one of these 10 ohms and I'll take one of my 10 ohms and I'll put the same voltage and the same current through both and see if one gets hotter than the other. If it does, that's going to tell me that there's less material inside it or whatever, or it's made of something different. The other test I'm going to do is we're literally just going to smash them open and see, is that a metal film, and does the film look like it's the same thickness and shape and everything as the legitimate. Sorry guys. The legitimate 10 ohm resistor. You know? Because we want to know. I know that the two stripes either end look a bit different to you, but it's just from a different manufacturer. It's brown on both resistors. And it's the same brown on each end. So, you know, they're supposed to be different wattage ratings. And I just can't wrap my head around it. So, I think I'm going to have to sacrifice a couple to work that out. I think what I'll do first is I'll put current through them and check out the temperature on each. And I'll pretty much just crank it up until I start to see them go black and discolor and smolder and whatnot. Very slowly, but because I want to compare how they both fail. Like which one fails quicker, if that makes sense. So I'll just set up, I'll pause the video and I'll set up to do that. Just give us a sec. Actually, you know what? I'm a bit of an idiot sometimes. I've just realised I should probably measure them for resistance to make sure the values are correct, unlike the capacitors and ceramic capacitors, because if the values are not correct, sorry, I just want to double check I'm holding the new ones. Yeah. If the values are not correct, there's no point in putting them in parallel and sticking a current across them, because they're both going to dissipate different amounts of power. No, wow, I measured up my multimeter and it's exactly bang on 10 ohms. It's literally. So these are actually 1% resistors. Alright, that's promising. Components with the right values, who would have thought? Should I say with the advertised values? Who would have thought? Alright, only got 0.7 of a volt here. I'm just going to slowly wind it up. I got my thumb and forefinger, index finger, sorry, on it, on each resistor, so I can feel if one's heating up quicker than the other. I'm just going up to about 1.5 volts. You know what, guys? They are both heating up identically. Now I know that's that could be my finger pulling the heat out of it, so I'll go up to 2 volts. And I'll go up to 1.75. Oh no. I don't even need to destroy these. Okay. That is actually getting hotter than that. Well, there you go. Oh, I'm now noticing the legs are thicker on my ones too. I do think I recall seeing something in the J-Car catalogue about them bragging about their resistors, saying that they've got half-watt resistors that come in the same size package as a quarter-watt resistor. So I guess they weren't lying. Back in there. Alright, well, I won't bore you guys with this, but in my own time, I'll just test the values with my multimeter and see if they're actually all 1%, and if they are, I'll put these away like I put some of the other components away. Just give me a second, I'm just going to go get a phone stand. Actually, don't worry, this works good enough for now. I just want to say quickly before I end the video, wow, have these got steel pins? Yeah. Okay. You know, these have all got completely different markings. Usually when I've gotten transistor kits and suspected that they're fake and put them in those drawers, it's one of the main things was because the batch number was the same across like 50 different devices. These are all different. I have seen these H331s. Is there a B331? D331. Wait a minute. B080. Okay, that's different again. Well, let's just take a 2N2222A. Test like one. Again, I'm going to have to just get that voltage breakdown tested before I can definitively say. So I will put them in drawers, but they'll be left in their bags because I'm just going to put them in the whoops, I almost took the phone upside down. I'm going to put them in the drawers that I've got to analyse transistors that I'm not sure if they're fake or not. But I'll leave them in their bags so that they're different, you know, same type of transistor in the same drawer, but different batches because they'll be in bags and the other ones will just be loose in the drawer. Alright. I'm still going to smash one of these open. And I'll tell you why. We don't have a clue what the composition is. Is it actually metal film inside? Well, you know what? I tested the tolerance and it was 1%, but you can get 1% metal films, carbons, can't you? Yeah, that looks like a metal film. That's metal film. I know this because metal film resistors have, if you can see where I'm scratching the side. Sorry. Why won't my phone bloody focus? What the hell? It's metal where I scratched it on a ceramic former. Alright. Well, it seems we got a score on the resistors. I'll measure a couple random values through the pile just to make sure they are 1%. I didn't just get lucky on that particular one. And organise these transistors. But yeah, I just wanted to make a video showing what I've got for upcoming test videos. I've got a whole basically box of transistors, box of MOSFETs, and what have I got coming? Oh, I've got some logic ICs. So I've got all the 74LS and 74HC series logic ICs that are starting to go obsolete. I've ordered a couple of kits of those. And I guess I'll order some logic analyzer chip testers and we'll see if they do what they're supposed to do. I've already got a lot of logic ICs scattered around the place, just in random different spots, like literally just everywhere. But yeah. Anyways, also, I guess I'll be digging into this S9 soon, because these phones have been sitting here for a few weeks. I think I might actually fix the other phone first and then come back to the S9 afterwards, but I'm not sure. There'll be a video on that but pretty soon. Alright guys, so stay away from this kit on Amazon. Alright, don't buy it unless you're willing to throw out all the capacitors or derate their values, and then you're still going to have to work out if the transistors are real or not, and the diodes. Or you can wait for me to get that tester and test them, and I'll tell you if they're real or not. But yeah. Alright, that's all for now. I wasn't planning on uploading too much tonight, but I just wanted to upload a couple bits of stuff, so I thought I'd show some components that I think are fake, and yeah, inform you guys of what's to come and what we're going to do with them. And I guess I've just given you a little bit of insight as to some projects that are coming up too, because I've told you guys that we're going to build a device to measure the junction gate capacitances of devices and RDS on figures. So you know I've got a high voltage breakdown tester coming, and you know that I'm about to make a couple bits of kit with that and the Atlas, and plus when I finish my high power, high current curve tracer project, I'll basically be able to write my own data sheets for an unknown part. That'll be pretty good. That's my goal. That's why I want to have all this stuff here, so that when I come across, because this is something that happens when you fix a lot of different random boards, you'll come across parts that have unidentifiable numbers or no numbers at all, and you've got to replace the part, but you don't know what it is. So if you can come up with a bunch of analyzing equipment that will allow you to analyze every single specification of a part, well, you can effectively form your own data sheet, can't you? So that's my end-term goal there. Alright guys, that's all on cheap components. There's only going to be another follow-up video where I test the breakdown voltages and stuff like that on these cheap components, and that's it, because like I said, this is not what I normally do, but I've seen a few people do videos on AliExpress specials and this and that and had really bad results. So I got these off Amazon and I've had mixed results, so I'll keep you guys updated. That's all for now. See ya.